Hi folks, this is the next edition in the YouTube channel from the point of view of doing some basic analysis and interpretation of stats using Excel as a tool. So I have some information built in, which is some samples of treated and controls here. It doesn't really matter which ones are which, and what we're going to do is do a t-test on these ones. And as part of that, we're also going to need to do some basic work on kind of standard descriptive statistics as well. So one of the things that we want to do is we'll calculate the mean, median, standard deviation, and that'll give us some insight into what the next step is with our data. So some of this you'll have seen already, but it's no harm just to redo them again quickly as we're doing as part of this. So the mean is obviously equal of the average, and then we're highlighting all of the data, and you've seen this, we've done this in one of the online sessions previously. The median is the same idea, but the formula is median in this case. So type in the formula, open the brackets, and then you can scroll to cover all of the samples. And then the standard deviation is STDEV for short, STDEV for short, and then again you just highlight the data that you're interested in and hit return. The reason it's showing up as the funny hash marks is that it has too many decimal points, so we just need to reduce those down a bit. Lastly, what's a useful one to use is count, because you want to know what the number of samples are in each case. So this is equal count, and there's a couple of different variants of it. We're going to use the count that contains numbers, which is just the plain count formula. Again, highlight the entire data range, and we'll see we've got 39 samples in the treated. So the easiest way to kind of work with this material and rapidly copy across a formula is just to pick that black box and drag it across, and you see immediately we've got the mean, standard deviation, so on for all of our samples. We've also counted them. The advantage of using formulas like this to count is that they will automatically be updated when I delete things. So I would say that that's possibly one of the best ways to go about doing this. So the next step is to actually do some further analysis of these using t-tests and so on. So we've got our data arranged, and now we're going to move on to doing a t-test with our data. Excel has built-in formulas for t-tests and for doing a variety of different statistical approaches, and I'll show you the two ways that you can actually apply those. So let's do the very, very simple t-test. Okay, I'll just put in a quick label saying t-test. And then after the label, I'm going to put in a formula. And the formula is, as you might expect, t-test. And when I hit return, you'll see it has a couple of options: array 1, array 2, tails, and type. So array 1, you can select by just scrolling on it with a mouse, or you can click on the actual blue and get some more information. But what I would suggest you do is just highlight the data that you're interested in. Okay, so in this case it's treated, and then I put a comma in, and now I can put in second array. You'll see it's highlighted again in blue. So my second array are my controls. We have tails, so we can have a 1 or a 2-sided distribution. Unless you have very good reason, you pick 2-tailed distribution, okay, which is 2. Now, the reason that you'd have for using a 1-tailed is that you're expecting your treated group to only be above or only be below your controls. Now, generally people will advise you to use a 2-tailed, because just with normal biological variation there will always be some high and some low. So just bear that in mind. And then at the end you have a couple of different options that you can pick. Paired. So paired would mean if the data was from the same person before and after treatment, for example. 2-sample equal variance is where you have 2 independent groups. So just like we have treated and controls, but the variance is roughly the same. Now, the standard deviation is the square root of the variance. So if this SD is pretty close, then you can use option number 2 here. If the variance is very, very different, then you're going to have to use the heteroscedastic approach, which is number 3. But really, 2-tailed with equal variance is what most likely you're going to come across. So I'm just going to put in a number 2 there for our overall t-test formula. So that's our entire formula, and when I hit return now, I will get a value for that, and it's in some scientific notation you can see, and this value is going to be the p-value. So it's 1.6 by 10 to the minus 6, okay, which is very low, and that would be a lot less than our normal sort of threshold for significance. Now, that doesn't make it more or less significant, it just makes it significant, and that there's a statistically significant difference between the treated and the control group. So that is a very simple way of getting the t-test for two comparisons, for two data sets in this case.